Okay, this is review for quiz on Monday. You have a quiz on Monday now. Number 3, number 4, 6, and this one here will be on it's going to be like on the test. Okay, so here. We'll do number 5. I didn't do number 5 in class. We'll do number 5 just in case you don't understand it. Stephanie casts a shadow of 1.2 meters. Okay, so here's Stephanie's shadow. We'll do it in black for a shadow. It's 1.2 meters. She is 1.8 meters tall. We'll do her in blue. 1.8 meters. And together they make 90 degrees. Right there, like that. Okay? A wind turbine casts a shadow of 10 meters. So wind turbine, here's a wind turbine, and its shadow is 10 meters. At the same time that Stephanie measures her shadow. Okay? At the same time Stephanie measures her shadow, draw a diagram of this situation and then calculate how tall the wind turbine is. Okay, there we go. Here's the wind turbine. W equals to wind turbine. Find that. The wind turbine and Stephanie are their corresponding sides. So we put W over 1.8 equals to the shadow of the wind turbine, which is 10, which corresponds to the shadow of Stephanie, 0.2. Multiply, that is 18 equals to 1.2 W. Okay. Divide by 1.2 and you should get your answer, okay? I'll leave you to that. This one here, this says they're congruent, triangle, TBG, TBG. Let's draw that triangle first. TBG is similar to triangle KPG. KPG. Okay, let's see the big triangles. What we know about the big triangle, this is 40. TB is 40. This whole thing is 70. So this is 70. Okay. The small triangle. That's all I know about big triangle. Small triangle, I know that this is 25 and this is 45. Okay. What are we trying to find? All the missing sides? We can find all of them. We can find this one, I believe. Can we? Let's look. For sure. Yeah, we can find that one. There's this one that's missing, and there is this one that's missing, and there's this one that's missing. So we can find all of them, right? Let's do this one first, right here. It didn't tell us what side to look for. I apologize. So we're just going to find them all. So, to find that one, KP over TB equals 2. We start out with the small, so we have these two here. Let's start out with small. PG corresponds to BG. KP over 40 equals to PG, which is 45 over 70. Cross multiply, get the answer. Divide, okay? So if I get a calculator up, cross multiply 40 times 45, 180, 1,800 equals to KP times 70, divide by 70, divide by 70. So KP equals to 180. We'll divide that by 70. We'll just make it easy. 25.7. Round it to the nearest 10. So this is KP is 25.7. Okay? And we can find TG by using, okay, we'll go up here. TG over KG equals to BG over PG. So KG over 25 equals to BG, which is 70 over 45. Oops. Sorry, the calculator is right there. Okay, clear it out. You go 70 times 25. That is 1750 equals to KG 45. Divide by 45. Your answer, divide that by 45. 38.9. KG is about 38.9. That does not sound right. Not at all. Aha, 52. That's my mistake. 52, not 25. 38, reason why I say it's wrong, because if this little piece right here is 52, this whole thing has to be more. So you guys need to learn to check to see if your answer is reasonable. I'm checking to see if my answer is reasonable. It was not. I found my mistake and it was there. Okay? So always check to see if your answer is reasonable. That was a good lesson on reasonable of an answer. 38 was not going to cut it based on that. So we do it again. You got how we do it? Well, you get the whole answer. Make sure you whatever your answer is, you minus 52 to whatever this answer is here to get this little piece. So that way we get every single little one, okay? All right. Based on the graph to your left, should say to your left, what is the coordinate for center dilation? Okay, the coordinate of center dilation is W, which is 1810. Okay, what is the scale factor used? 1, 2, 3, 4. Scale factor of 4 or 1/2. 4 for enlargement, 1/4 for reduction. So if you put scale factor of 4, 4 for enlargement, that's correct. If you put a scale factor of a fourth for reduction, that means you start out, this is your original triangle, and then you reduce to this small, or you start out with the small triangle and you enlarge it by a scale factor of 4. Find a distance of yx. Use Pythagorean theorem. Count. 2, 4, 6, 8. 4 times is 16. So 8 squared plus 16 squared equals to c squared. You finish that. Find the rate of change for and the y-intercept for line yx. Okay. Okay, let's check to see if this is consistent. This looks right here. Here. Oh yeah, rate of change is 2 over 4, which is a half. Oh yeah, look. Yeah, look right here, look. So the rate of change is 1 over 2. Okay, and the y-intercept's right here, look. 9. So the rate of change is a half. You can use the graph. You don't always have to do, if you're confused on this, you can use 2 and 10, and this one here is 18 and 18, right? You can do that and find the rate of change that way. But you can also use the graph, which I haven't emphasized a lot, but I've been doing the equation, but you can always use the graph and look. Sometimes the graph, just to make sure, like see here, the rate of change is the same, it's a half, 1 over 2, 1 over 2, just like that one. That's why they're parallel, right? And just double check with math, it's just to make sure you get 18 minus 10 and 18 minus 2. You get 8 over 16, which is a half. And the y-intercept is at 9. Rate of change is 1/2. Y-intercept is 9, or 0.9. Or you could use y minus y1 equals to m parentheses x minus x1. Y minus 10 equals to 0.5 parentheses x minus 2. And you get y minus 10 equals to 1/2 x. This times that is equals to 1, add 10, y equals to 1/2 x plus 9. Notice, same here, y-intercept is 9. Okay? That's the other way you would have done it, and that's what I've been telling you, but if you can use the graph, you do. If you understand using the graph, fine. If not, double check it with the math to make sure you're right. If you're not sure, because if you look at this graph here, I didn't use a ruler and it's such a long line, it's not precise. See, it's not on that corner. It was a guess. Okay? So you use the math to make sure. It's really important. Write a linear equation that will create no solution. Okay, we know solution, just make sure the rate of change is 1/2, and it can be any, y-intercept can be anything you want it to be. We'll just make it 10,000. Okay? Explain why. Why it's no solution, because the rate of change is the same, therefore the lines will be parallel, and they'll never meet to make a solution. That's how you explain it. Write that out. You guys know how to do that. Okay, the center is 1, 1. Dilate, that means we're going to make it larger or smaller on a coordinate plane using point 2, 1 as the center of dilation, and a scale factor of 2. This is going to be an enlargement. Okay, this is scale factor of 1. It's 5, so we go 5. And this would be B prime. This would be C prime. That would be our answer. That's it. The back one, graph, 2, 2. Let's change this. Graph, triangle ABC with the coordinate. A is 2, 2. B is 3, 5. C is 5, 2. That's one of them. Okay, this is ABC. Okay. Dilate triangle ABC on the coordinate plane using the origin 0, 0. That's 0, 0 right there. As the center of dilation and the scale factor of 3 to form triangle A prime, B prime, C prime. Okay? Scale factor of 3. So we're going to make an enlargement. Because the center is at 0, 0, we just multiply all these by 3. And label it A prime, B prime, and C prime. Okay, that's easy enough. A prime is 6, 6. B prime is 9, 15. C prime is 15, 10. Okay. So A prime is 6, 6. Nine, 15. And 15, 10. You okay, Bryce? Come here, big guy. That doesn't look right. 5, 2. Oh, this is 6. 3 times 6. Gosh darn it, I cannot believe that carelessness I saw. See, it does not look right, so I double check my work. 15, 6. You need to do the same, kids. If it doesn't look right, double check. Redo. Check for reasonableness. That's Common Core standards. It's called good math. Using your brains. See if your answer is reasonable. Okay, because the center's at the origin, 0, 0, we connect all the A's together. It's A prime, B prime, C prime. All the B's together and all the C's together. Make it a little dash like that. There you go. Get three-dimensional image. Find the intersection of AB and AB and B and C prime. Let's see. A is 2, 2. B is 3, 5. And the other one is B prime, which is 9, 15. And C prime, which is 15, 6. Okay, find the lines of those two, the equation of the line. Let's see if it's... Well, I know this much. Without using a formula, I can use this little piece to find my rate of change right here. AB, it's up 3 over 1. 3 over 1, up 3 over 1. That makes the rate of change of 3 over 1, which is 3. Okay? And here I can use the graph BC, this one here. Oops, sorry. Go down. This graph is going down, as you can see. This graph is going down. It's a negative graph, B to C. It's going down how many? 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. 8 over 6, which is 4 over 3. 8 over 6, which is 4 over 3. The math is just as fast if you just minus this. 9 over 6. Let me see. It's 9 over 6, not 8. 1, 2, 3, 4, 5, 6, 7, 8. I may have graphed wrong. Yeah, I did. I did graph wrong. Look at that. This is why math is more superior than counting, because I graphed B prime wrong. Oh, look at that. So those of you who said you found my error, you did not. I changed it afterwards. It's a good thing I checked myself. See, we always check using math. I did y2 minus y1 and I got 9. So it's 9 over 6, which is 3 over 2 is my rate of change. 1.5. So we do y minus y1. It's easier for me. It's just as easy to use formula than counting the graph. But the graph is another way for you to do. Okay? y2 minus y1 is much easier for me than counting. And press the x minus x1, y minus 2 equals to 3 parentheses x minus 2, y minus 2 equals to 3x minus 6, add 2, y equals to 3x minus 4. Yeah, it looks right. Negative 4. Based on the graph, it's going to come down somewhere, yep, at -4. Double checking. Okay, here y minus y1 equals to m, okay, I have the formula over on the other side, on y minus 15 equals to, change this to 1.5x, minus x1, which is 9, y minus 15 equals 1.5x minus, use a calculator really fast. I could probably do it in my head faster than a calculator. Not 1.5, but it double checks times 9, 13.5. Add 15. Y equals to 1.5x. 1/2 x. 3/2 x chain plus 1.5. Right? 15. Yep, that's right. And then put it together. 3 using substitution. 1.5x. So look how interchangeably I use that. To my favor, whichever one, if a decimal helps me, if it's a fraction help me, I use them both. In this case, I need it as a decimal. 1.5x minus 4 equals to 1.5. Add 4. 1.5 equals to 5.5. Make sure you don't forget the x. Divide by 1.5. And then you get what x is. Okay, clear it out. 5.5. Divide that by 1.5. 3.2 1 or 3.7. Let me do that. And then to find y, you substitute this into that, and then you get your y here. Okay? That we found the exact, or about, because we round our thing, so it's basically 6 repeating is 2/3, okay? 2/3, 3 and 2/3, which is 10, 11 over 3 times 3. It's 11, add 4. 11 minus 4 is 6. 7. So 3, you'll be more accurate, 3 and 2/3, and 11, that's 11 minus 4, 7. That's the exact. This is the rounding one. Both ways. You guys need to know that 2/3 is 0.6666 and 1/3 is 0.3333. Stuff like that. Those are common numbers. You'll eventually need to memorize for your own benefit. But right now I'm not having you. I'm letting you round. Okay? That's it.